Good morning and welcome to Friday, May 8th. This is AP Stats. Today I'm going to give you a brief review of the Chapter 5 probability rules and then set you free to do your work. So real quick summary of Chapter 5. The probability of an event occurring are the number of favorable outcomes over all outcomes. Remember, we call all outcomes the sample space. And the sample space, again, contains all possible outcomes of event E. While we're here, remember that the probability of an event has to be no less than 0, no more than 1. And also remember that the complement of an event equals 1 minus the probability of that event. Either it happens or it doesn't, so they add to 1. So far, so good? Okay, great. The intersection of two events is described this way. The intersection where two events happen. So it's an and word, or this and that. And the intersection of two events is equal to their product if they're independent. If and only if, IFF, we have independence. Independence. Okay, good. Okay, if there's independence. And another way we can find the probability of two events intersecting, regardless of whether or not they're independent, is with conditional probability notation, P of A times P of B given A. That's also going to equal the intersection, whether or not we have independence. Okay. Those are independence. Let's also remember what union was. That was the symbol, looks like a big U. And it means or. The union of two events is the probability of A plus the probability of B minus any overlap, which is the intersection. So P of A plus P of B minus P of A given B, not given, intersect B. And that's going to be our union rules. Don't forget to subtract any overlap. Otherwise, you'd be double counting the probability of the intersection. All right. We also have conditions. I know that I've shown you this notation before, just now. That's the probability of A given B has occurred. And if you want to find it out numerically, it is their intersection divided by the probability of B. So we did a problem like this the other day where we had the left-handed people who were single birth versus multiple birth, and the question was, what's the probability of a person being a multiple given we found left-handed person? So it was the probability of left-handed and being a multiple birth divided by the probability of being left-handed, so that we had the event given as a condition. All right, next up we have ways to prove independence. We had to have that a lot. All right, so I'll say they're independent if. Independent if, we already said P of A times P of B equals P of A intersect B. That was one of our ways to prove independence. Also, if P of A is equal to P of A given B, which means probability of the event occurring doesn't change whether or not the other event had occurred. And in the other direction, P of B equals P of B given A. It's the same thing, really. What does it mean to be mutually exclusive? We also had a word called disjoint. So disjoint events, can't spell today, let's try that again. Disjoint events, we also call it mutually exclusive. I'll abbreviate that ME. What happens with mutually exclusive events? Well, they cannot occur at the same time. So what is the numerical or formulaic way that we prove two events are disjoint? If their intersections probability is 0, which means they cannot occur at the same time, we have disjoint events. If they can occur at the same time, we call them joint events, or not mutually exclusive. Okay, so far so good. Now just a little conversational point. We had 3 types of probability, and we didn't focus much on the third, but there was theoretical or classical probability, which is what should happen based on the numbers. When I roll a die, the probability of rolling a 3 is 1 in 6. It's just statistical, classical, theoretical probability. If I actually conduct an experiment, I roll that die 12 times and I find that 3 of them were the number 6. That's my empirical probability. It's what actually happens. And it doesn't always have to mesh up with the, or match up to the theoretical. However, the law of large numbers tells us that the more and more a trial is performed, the closer and closer our empirical probability will come to our theoretical. The third type, not much touched on, was called subjective probability. It's essentially based upon past experience with subjects similar to the one in question. For instance, how long will it take that ACL surgery to heal? Well, 217 days was the average length of time for the standard procedure for the ACL surgery. What do we base that on? Other people like person X who have gone through the ACL surgery and have recovered. It's subjective probability. There's usually a margin of error. When you break a bone or have a surgery, they'll say, well, it'll take 4 to 6 weeks to heal. They're basing that on other people similar to you, your age group, your health level, the type of injury you had, and how long it took them to heal. It's called subjective probability. We looked at two-way tables a lot this year, and the conditional distributions and the marginal distributions. We looked at Venn diagrams as it pertains to this unit with probability quite extensively, so look back at your notes. We also looked at tree diagrams to create the probability branches to see what the likelihood was of one event than the other. Go through your notes. You have plenty of examples of that. So what I'd like you to do now is the attached work. It is the Frappy from Chapter 5. And that's the homework for the weekend. Again, continue to review your notes. Review all chapter notes because, again, we have our AP exam coming really soon. So we are basically 2 weeks out now. Review it. Don't let up on it. And we will continue on Monday. Have a great weekend.